4-3, January 2013, question 8. About this in partial fractions, the first thing we need to check is that it's proper fraction, i.e. the power of x on the numerator is not equal to or greater than the denominator. Numerator's x to the power 1, denominator's x squared. That means I can say that it's going to be a over 2 minus x plus b over 2 plus 3x. I'm going to go through and multiply every term by 2 minus x upon 2 plus 3x. When we do that with the first fraction, the numerators and denominators are going to cancel. Be left with the 2 plus 7x. When we do it with the next fraction, the 2 minus x's will cancel and will leave us a times 2 plus 3x. And when we do it with the third, the 2 plus 3x's will cancel and leave us with b upon 2 minus x. I'm going to let x equal 2. So 2 plus 14, which is 16, a upon 2 plus 6, which is 8, and 2 take away 2 is 0, so the b is eliminated, and we have that a is 2. If we substitute in minus 2/3, then the x will disappear in the a, and we'll be able to work out b. I don't like working with fractions, so I'm going to use 0 instead. So I have that 2 equals 2a plus 2b. So 2 has to equal 4 plus 2b. 2b must be minus 2, and in this case b is minus 1. Last thing we need to remember to do is write out the fraction. So it's 2 over 2 minus x minus 1 over 2 plus 3x. To expand 2 plus kx to the power minus 1. We can't expand with a 2, we need to make that 1, so we'll take a factor of 2 outside. We have to remember that's to the power minus 1. Inside the bracket, that leaves us with 1 plus kx divided by 2 to the power minus 1. So I'm going to have a half outside, and inside I'm going to have 1 plus n x plus n minus 1 all over 2 factorial x squared. That's going to give us a half upon 1 minus kx over 2 plus, and we have to be careful here, these are going to cancel, but inside the bracket the k gets squared and the 2 gets squared. So that's going to be k squared x squared over 4, and then expanding my brackets I get an answer of a half minus kx over 4 plus k squared x squared over 8, and that's valid for the modulus of kx over 2 is less than 1. Modulus of x is less than 2 over k. I'm going to rewrite this in the partial fractions, which was 2 over 2 minus x minus 1 over 2 plus 3x. So that's 2 upon 2 minus x to the power minus 1 minus 2 plus 3x to the power minus 1. In the first one, we're going to use our answer to part 2, but we're going to let k equal minus 1. And in this expansion, I'm going to let k equal 3. That's going to give us 2 upon a half minus k x over 4 plus k squared x squared over 8 minus 1 half minus kx over 4 plus k squared x squared over 8. Combining and simplifying, 2 times a half is 1, take away a half is going to give us a half. 2 times x over 4 is x over 2, and x over 2 take away minus 3x over 4 is x over 2 plus 3x over 4, which gives us plus 5x over 4. 2x squared over 8 is x squared over 4. Take away 9x squared over 8 is minus 7x squared over 8.